Hi students, once again welcome back to this tutorial and we can continue with the arithmetics of binary numbers, and in this video we can discuss about the remaining two types of binary arithmetics. They are the multiplication and division. So we can start with the multiplication. The multiplication of binary numbers are exactly like the multiplication of numbers in the decimal system, right? So in the binary system we are available with only two bits, the 0 and 1. Okay, so consider one multiplication of 1100 with the multiplier 111. This is the multiplicand and this one is the multiplier. So start from this bit of our multiplier. We need to multiply this multiplicand using the LSB bit of multiplier. It is 1. So if the bit is 1, we need to write the bits of multiplicand as it is here as a partial product. Okay, so start from this position and proceed towards left and write the 0 here, 1 and 1. Okay, so next we need to multiply this number using the next bit of our multiplier, that is this one. So again it is 1. Multiplying a number using 1 means the number itself. So in this case we need to write the partial product starting from this location and proceed towards left like this. The 0 comes here, the 0 here, 1 and 1, right? So we can go for the multiplication using this one. In this case we need to write the partial product starting from this position and proceed towards left. So this 0 comes here, the 0 here, 1 and 1. Okay, so now we have no bits available here in this multiplier. So these are the three partial products available by multiplying using three different bits of this multiplier. Now we can add these partial products together. So the 0, write down this 2, 0 and 0. 0 plus 0 means 0 itself. Next 1 plus 0 plus 0 means 1. Next 1 plus 1 is actually 2. 2 in binary is 1 0. So place that 0 here and 1 as a carry to the next level. Okay, so 1 plus 1 plus 1. Actually it is 3. 3 in binary is 1 1. Right? So the LSB 1 of 1 1 is placed here in this position as the sum value, and the next one is passed as a carry to next level. Now we can add these one together and get a product. 1 plus 1 is actually 2. 2 in binary is 1 0. The LSB bit of 1 0 is 0, which is placed here. Okay, here we have no other bits remaining as a part of this partial product. So the next bit of 1 is directly placed here. Right? So this is the final product value of this particular multiplication. Okay? So consider whether this value, the generated product, is exactly equal to our product of this decimal equivalent multiplication. Okay, this one is actually 12. This is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. 2 raised to 3 is 8, 2 raised to 2 is 4. 8 plus 4 is 12. Okay, 12, and this one is 2 raised to 0, 2 raised to 1 and 2 raised to 2. 4 plus 2 plus 1. That is 7. Means 12 into 7. This is actually 84. Okay, check whether this binary number is equivalent to this 84 or not. This is 2 raised to 0 at the position, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5 and 2 raised to 6. Then here these two terms are 0. So the products are also 0. This is 1 into 2 raised to 2. And here 1 into 2 raised to 4 and 1 into 2 raised to 6. So while adding 2 raised to 6 plus 2 raised to 4 plus 2 raised to 2. That is 64 plus 16 plus 4. That is 84. Exactly equal to this decimal value 84. So the multiplication is correct. Another example. Here multiplicand is 1010. Multiplier is 1001. So start the multiplication from the LSB bit of multiplier. So while multiplying with 1, we get the partial product exactly equal to the multiplicand. So write this multiplicand starting from this position and proceed towards left. So this 0 comes here, 1 comes here, 0, then 1. Next is 0. Next bit of our multiplier is 0. So multiplication with 0 means 0 itself. So here we have 4 bit in our multiplicand. So we can write like this. Starting from this position, we can write 40 like this. Okay, 0 into 0 is 0, 0 into 1 is 0, 0 into 0 is 0 again, 0 into 1 again 0. Again, here we have the multiplier bit is 0. So starting from this position, we can write 4 zeros towards left. 0 into 0 is 0, 0 into 1, 0, 0 into 0, 0, 0 into 1, 0. Right? Next bit of this multiplier is 1. Multiplication with bit 1 is the number itself. So we need to write the multiplicand directly down here. So starting from this position, proceed towards left. So this 0 comes here, this 1 comes here, this 0 comes here, 1 here. Right? Next, here we have no other bits remaining here in this multiplier. So we can stop here and we can add now all these partial products. So here we have no other bits. So we can write this 0 down here. This 1 plus 0 is 1. Next 0 plus 0 plus 0 is 0. Next 1 plus 0 plus 0 plus 0. That is 1. This is 0 plus 0 plus 1. Again 1. This is 0 plus 0. 0. This is 1. Okay. So this is our final product value. Now we can check the correctness of this product. So this particular binary number is 1010 means 10 in decimal and 1001 is 9 in decimal. 10 into 9 is actually 90 in decimal. Okay, now we can check whether this product value is equivalent to this or equal to this 90 or not. So we can find out the place values. This one is 2 raised to 0. This is at 2 raised to 1. 1 into 2 raised to 1 and 2 raised to 2 is 0. This is 1 into 2 raised to 3, 1 into 2 raised to 4 and this is 2 raised to 5. This term is 0 actually. Then 1 into 2 raised to 6. This is 64, 16, 8, then 2. So adding all these values together, we get the result 90 is exactly equal to this product value. Okay, so this is the rule of multiplication of binary numbers. And the rule is exactly equal to the rule of multiplying decimal numbers. Okay. So now we can discuss about the division. So here, this is the example. This is the dividend and this one is the divisor. Now we can consider the division of this particular dividend and divisor. Right? And the rule of division is exactly equal to the division of decimal numbers. Okay, so here first consider the MSB bit of our dividend, which is 1. Here the divisor is 1, 1, right? This 1 is less than 1, 1. So we can't divide this. So put a 0 here. And next consider the 0 along with this 1. Okay, so now it forms 1, 0. 1, 0 in binary is actually 2, and this 1, 1 in binary actually indicate 3 in decimal. This 2 is actually less than 3. Again, the division is not possible. So we can put a 0 here, right? So we can combine these 0 along with this 1, 0, right? So it forms 1, 0, 0. 1, 0, 0 is equivalent to decimal 4, right? So 1, 0, 0 is actually greater than our 1, 1. 1, 1 means decimal 3. So we can divide now. How many times? Only once. Because in binary we have only two bits are possible. One is 1 and other is 0. We can put 1 here. 1 into 1, 1 means 1, 1 itself. So starting from this position, right towards left, this 1, 1. Now we can subtract this 1, 1 from this 1, 0, 0. Right? So here it is 0. From 0 we can't subtract this 1. So we need to borrow from our neighbor. Right? So this neighbor is again 0. So consider the next neighbor. Here it is 1. So we need to borrow from this position. So after borrowing, this position becomes 0 and this becomes 2. Okay, so we can, in this position now we have this 2, so we can take one value from this location or we can pass one value from this location to this. Now it become 1 and this position become 2. So from this 2 we can subtract this 1 and here it form 1. This 1 minus 1 is 0 actually. So here it is already 0. No need to write here. Okay, so this is the first division. Now we can consider the next number. We can combine the next number next bit of our dividend with this bit. So write down this one here. So this is 1, 1. Right? This 1, 1 is actually 3. This is equivalent to our divisor. Right? So we can divide. 1 into 1, 1 is 1, 1. Okay? And subtract. So while subtracting, here it is 0, here again it is 0. Okay, and we can now put the 0 down here. This is 0. The 0 is actually less than our divisor. So we need to combine next number with this value. And also we need to put a 0 here. Right? This, after combining this 0 with the reminder, we can't divide using this 1, 1. So we need to put a 0 here and combine next number, next bit of this dividend with this reminder. Now it forms 0, 0, 0, 1. This 1 is again 0, 0, 0, 1 means 1 itself. 1 is again less than our 1, 1. 1, 1 means 3. 1 is less than 3. So we can't divide again. So put a 0 here and combine this one with this reminder. Right? Now it forms 1, 1. Means 3. This is actually 3 now. 3 is equal to our divisor 3. So we can now divide. Means how many times? Once. So 1 into 1, 1 is 1, 1. Now we can subtract. This is 0. So now we can we have completed our division. Okay, now we can check the correctness. So here it is. This 1 is at position 2 raised to 0. That is 1. And this is at 2 raised to 1. That is 2. This 2 raised to 2 is 0. And 2 raised to 3 is 1. So 1 into 2 raised to 3, 8. These two terms are 0. And finally 2 raised to 6, that is 64. So while adding, we get this number as 75, and this is actually 2 raised to 0 plus 2 raised to 1. 2 plus 1 is 3, right? So while dividing 75 with 3, we get a result 25. That is 75 by 3 is, the quotient is actually 25 with remainder 0. So here check this one. This is actually 2. This is actually 2 raised to 0. That is 1. 2 raised to 1, 2 raised to 2, 2 raised to 3 and 2 raised to 4. 2 raised to 4 is 16 plus 8 plus 1, that is 25. So the answer is correct. So here it is another example, the division of 11001 by 100. Okay. So first consider this one. This 100 means actually 4 in decimal. Okay. So this 1 consider the MSB bit of our dividend, that is 1. 1 is less than this 100. 1 is less than 4. So put a 0 here and combine the next the next bit with this MSB 1. So it form 1 1. Again 1 1. 1 1 means 3 in decimal. 3 is less than 4. So put a 0 here and combine the next 0 also with this 1 1. So it form 1 1 0. 1 1 0 in decimal is actually 6. Right? The 6 is actually greater than our 100. 100 means 4. So 6 is greater than 4. We can divide. So put 1 here. 1 into 100 is 100. Now we can subtract the 0, 1. Okay. And we can combine the next bit of our dividend with this remainder. Right? So this is now 100. This is 4 actually. 4 is equal to our divisor 4. Right? Here it is 4 and here also 4. 100 means 4 in decimal. These two are actually equal. Now we can divide. 1 into 100 is 100. Right? So while subtracting we get 0. And we can now put this one, the remaining bit of our dividend, combine this remaining bit with the remainder. Now it form 1. But the problem is 1 is less than our divisor. And here we have no other bits remaining in this dividend. So we need to put 0 because this 1 can't divide it using this 4. So put a 0 here and here we have no other bits remaining. Right? So put a fractional point or decimal point here. Then combine a 0 with the remainder. Now it form 1 0. 1 0 in binary means 2. Right? But 2 is less than our divisor. Divisor is actually 100 means 4. 2 is less than 4. Right? So we can't divide this 2 using this 4. So again we need to put a 0 here and combine one more 0 with the remainder and this form 100 now. So these two now become equal. So we can divide. So 1 into 100 is 100. We can subtract and get the remainder 0. Now we completed our division. So remainder is 0 and quotient is this. Okay, now we can check the correctness of our result. This 11001 is actually 25 in decimal and this one is 4 in decimal. 25 by 4 is actually, the expected result is 6.25. Okay, so here it is 00110.01. This 00110 means actually 6 in decimal and this 01. 0 into 2 raised to minus 1 plus 1 into 2 raised to minus 2. That is actually 0.25. So the result is exactly equal to the result of division in decimal by 25 by 4. Okay. So thank you.